Hello, I am Rahul Waghel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University. Welcome you all to the course on Industrial Automation and Drive. Today we begin with our 15th lecture on PLC Timer Programming Part 2, focusing on off-delay timer. In the previous lecture we covered the mechanical timing relays, PLC timer instructions, and the examples and related to the T-on timer. So in this lecture we will start with the PLC off delay timer. As you can see in the diagram also, the off delay timer will keep the output energized for a time period for the rung containing the timer has gone false. You can see in the diagram and the timing diagram for the off delay timer instructions. In the diagram you can see my my T off timer is connected to the input switches. The address of input switches is represented by I:0/0 and the timer address is represented by T4:3. The preset value we provided is 15 and the done bit is represented by T4:3/DN is connected to the second rung and the output is connected to the done bit. The address of output is represented by O:2/1. The operation of the circuit follows the following step. In the first step, initially when the input is off, the timer remains in the off state with the enable bit, done bit and the timer timing bit all turned off. That's why En is equals to 0, done is equals to 0 and the timer timing bit Tt is equals to 0. In the next step, when the input is turned on, the timer enable bit is and the done bit is activated. Means when we provide the supply to our timer, our input will become high, the enable is become high and the done bit is also high. That's why En represented 1 and Dn is also represented by 1. But in this case, our timer does not start counting. However, the timer timing bit remains in the off state. That's why Tt is equals to 0, right? In the next step, when TOF means off delay timer start timing when the instruction goes from on to off or from true to false. In this case, timer timing bit TT bit it is become 1 and enable bit becomes 0 and the done bit become 1. And when the accumulated time equals to the preset time, the output is reset to the 0. In this case, Tt is equals to 0, enable bit becomes 0 and the done bit become 0. So T of timer process, I guess you clear the process. I am again repeating. T of timer is just opposite to the T on timer. In this case, when I provide input to our timer, our enable bit and the done bit become high, but timer doesn't start counting, right? And when I stop the timer, means when I stop supply to the timer, that's why on that case our enable bit becomes 0 and our done bit become 1 and our timer start counting. That's why Tt become 1, right? That's why Tt become 1 and after that when the accumulator value is equals to the preset value, our done bit is also become 0 and Tt bit is also become 0. So these operation of the T off timer is just opposite to the operation of T on timer. To understand, let's take another example. In this example, suppose we have one input A and the three output B, C, D connected to the enable bit, timer timing bit and the done bit respectively as shown in the figure. As you can see in the figure, our T of timer address is represented by T4:0 and is connected to the input switch A and the address of input switch is represented by I:0/0. And you can see in the second rung my output B is connected to the enable bit and in the third rung my output C is connected to the timer timing bit and in the last rung my output D is connected to the done bit, right? And the address of the output B is represented by O colon 0 slash 0, output C is represented by O colon 0 slash 1, and output D is represented by O colon 0 slash 1, right? So let's take the first case. In the first case, when the A is off, means my switches remain their own states. As you can see, the switch A is represented normally open. That's why my switch is in normally open state. It doesn't change their states. That's why my timer doesn't get any supply. If the timer doesn't get any supply, that's why enable bit is 0, done bit is 0, and TT bit is 0. That's why all the three inputs for rung 2, 3 and 4 become 0. That's why the output connected to that rung is also 0. That's why you can say the output B, C and D become 0. In the next case, when I press the input switch A, as you can see in the diagram, when A is on, my T off timer gets the supply. That's why you can see that the enable bit and done bit become high, right? You can see in the rung 2 and the last rung, the enable bit and the done bit is high. That's why the input switches represented by enable button and the done bit is high. And when the input is high, the connected output has also become high. That's why the output B and output D becomes high, right? But you can see in this case, my timer doesn't start counting, right? My accumulator value is remain 0. You can see in the diagram. This is most important to understand the T off timer, because in case of T on timer, when I provide supply to my timer start counting, right? But in case of T off timer, when I provide the supply, my enable bit is high, my done bit is high, but my timer doesn't start counting, right? This is the basic difference between T on timer and T off timer. In T on timer, when I give the supply, my time enable bit is high and my TT bit is high. But in case of T off timer, when I provide the supply, my enable bit is high and my done bit is high, right? So you can see in this case, when I provide the supply to my T off timer, my enable bit is high. That's why the output B is connected to the enable bit is high, and the done bit is high. That's why output D is also become high. But TT bit is 0 because my timer doesn't start counting. That's why TT bit becomes 0. That's why the output connected to the TT bit, that is output C, is 0. Let's see the next case. When I again press the input, means when input become off, means when I close to the input switches, means initially my input is off, then I press the input or my input become 1. In the third case, when I again close the input, that's why A is represented by 0. When A is 0, means again A is in their previous state, normally open state. That's why my timer doesn't get any supply. That's why enable bit becomes 0. As you can see in the diagram also, my enable bit becomes 0. That's why my output B is become 0, because output B is connected to the enable bit. But you can see in this case, when the timer doesn't get the supply, my TT bit become high because my timer start counting, and the timer start counting from 0 to the preset value. As you can see, my accumulated value is 3 and my preset value is 5, right? So till 5 seconds my TT bit become high. That's why the output connected to the TT bit is also high for that time period, for the 5 seconds. So output C is high for the 5 seconds, and the same time my TT bit is also become high, right? But in this case also you can clearly say that my done bit is also become high, right? So In this case, when I off the input switch, my enable bit becomes 0, my TT bit becomes 1 and my done bit becomes 1. That's why output B becomes 0, output C becomes 1 and output D becomes 1, right? Let's take the last case when the accumulator value is equals to the preset value. In this case, my timer stop counting. That's why TT bit becomes 0. That's why output connected to the TT bit is also becomes 0. In the same way, my done bit becomes 0. That's why output connected to the done bit is also 0, right? I think you clear the operation of T of timer. Again, I am repeating this process. Initially, my T of timer is connected to the switch A. In this case, all the three inputs, all the three outputs, you can say, enable bit, done bit and TT bit is 0. And second case, when I press the input switch or when I supply to my timer, when I supply to my T of timer, my enable bit become 1 and my done bit become 1. But timer doesn't start counting. So TT bit becomes 0, right? And when I press my switch A or when I cut the supply to the T of timer, means my timer input initially is 0, then it goes 1, then it goes again 0, right? On that case, my timer start counting, and in this time when the timer start counting, TT bit become 1 and enable bit becomes 0, and when the accumulator value is equals to the preset value, my done bit is also become 0, right? Let's take another example for the T of timer. Suppose we have two motors M1 and M2 with the green and red switches to the turn on them and turn off. When the green button is pressed, both motor will turn on. When the red button is pressed, M1 will turned off after 10 seconds and M2 will turned off after 10 seconds, right? In the first case, when the green button is 0, and you can see in the diagram also, my green button or my start button is represented by I:0/0 and my stop button is represented by the red switch also, and the address of the red switch is represented by I:0/1. And my first T of timer, that is T4:0, is connected to the binary input, binary button B3:0/0, and the same time the second timer, that is T4:1, is also connected to the binary input. But you can see my first T of timer, the preset value is 10 seconds, and the second T of timer, the preset value I am taking is 20 seconds, right? And the motor 1 is connected to the first timer done bit, that is T4:0/DN bit, and the motor 2 is connected to the second timer done bit, that is T4:1/done bit, right? The output of the motor 1 is represented by O:0/0, and the output of the second motor, the address of the second motor is O:0/1. So let's take the first case. When the green button is a stop or green button is 0 or green button is off states, means it doesn't change their state, it remains their previous state, that is normally open. So when the green is a stop, my binary output becomes 0, and when the binary output becomes 0, my both timer doesn't get any supply. That's why enable bit and done bit becomes 0. That's why motor 1 and motor 2 is also it is in off state, right? In the next case, when I press the start button, you can see when I press the start button, my binary output B3:0/0 become high. That's why my two T of timers, that is T4:0 and T4:1, gets the supply, and if the both timer gets the supply, the enable bit and done bit of the both timer become 1. That's why you can see my motor 1 become 1 and my motor 2 is also become 1. 1 means it is on stage, right? You can see in the diagram, motor 1 is also high and motor 2 is also high, right? But you can see my timer doesn't start counting. You can see the accumulator value becomes 0 for the for the timer 1 and for the timer 2, right? Let's take the next case. In that case, when I press the red button, you can see in the diagram, when I press my red button, my red switch changes their state from normally closed to normally open. That's why in the first rung, my binary output becomes 0. That's why my binary output becomes 0 means my timer doesn't get any supply. That's why my both the timer start counting from 0 to the preset value. My first timer preset value is 10 seconds and the second timer preset value is 20 seconds. So for the first timer, preset value is 10 seconds means after 10 seconds the done bit becomes 0, right? So timer start counting from 0 to 10 seconds. In that 10 second also the done bit is high, but after 10 second my done bit becomes 0. That's why my motor 1 will become 0, right? And the same time my second timer is also counting from 0 to 20. So initially 10 second is common and next 10 seconds my motor 2 is on, and when the accumulator value is equals to the preset value means my second timer is counting till 20 and motor 2 is high, and after that my motor 2 is also become 0, right? As you can see in the diagram, in the third case, when the both accumulator value is equals to the preset value means the first timer 10 second is equals to the 10 second, preset value is equals to the accumulator value, and in the second timer accumulator value is equals to preset value means is equals to 20 second. My both the motor 1 and motor 2 become 0, right? Because of the operation of T of timer. I think you understand the procedure and the operating principle of T of timer with this example. Let's take another example of T of timer. Suppose we have three motors M1, M2 and M3 with green button and red switches to turn on and off. When the green button is pressed, both motor will turn on, and when the red button is pressed, M1 will turn, and after 10 seconds M2 will turn off, and after 10 seconds M3 will turn off. So let's take the solution for this. In this diagram you can see the start button is represented by I:0/0 and the red button is represented by I:0/1. My motor 1, motor 2 and motor 3 is connected with the binary input switch B3:0/0. My motor 2 is connected to the T4:0/done bit, that is done bit of my first timer, and my motor 3 is connected to the done bit of my second timer. The address of the motor 1 is represented by O:0/0. Address of the second motor is represented by O:0/1, and address of the motor 3 is represented by O:0/2. Let's take the first case. When green is 0 means initially there is no connection, no start button is pressed, means start button is in their initial state, normally open. That's why the binary output becomes 0. So the input address of the binary output switch in the second rung, you can see the B3:0 is in off state. That's why motor 1 is also off. At the same time, the binary output address provided to the input switch of the T of timer. That's why my first timer T4:0 is also doesn't get any supply. That's why also enable bit and done bit becomes 0. That's why my motor 2 is also 0 state. At the same time, my second timer is also doesn't get any supply. That's why my motor 3 is also is in off state. In the next case, when I press the start button, as you can see in the diagram, the green button is pressed. When I press the green button, my first rung is completed. That's why the binary output is become high. As you can see in the diagram, the B3 colon 0 is become high. That's why the output connected to the B3 colon 0 become high. So my motor 1 is in the my motor 1 is become high. At the same time, you can see my timer 1 is also getting supplied to the binary output address. That's why my timer 1 is also high. That's why you can see the enable bit and done bit become high, and the motor 2 is also high because my motor 2 is connected to the first timer done bit. As you can see in the fourth rung, the done bit is high. That's why motor 2 is also high. At the same time, you can see my second timer is also high because of done bit of first timer. That's why enable bit is done bit become high. That's why motor 3 is also high because it's connected to the second timer done bit, right? So in this case, means again I am repeating, when I press the start button, my binary output become high, and the binary output is high. Because of that, my motor 1 become high. At the same time, my binary output supplied to the timer 1. That's why my motor 2 become high, and my first timer done bit is connected to the second timer. That's why my motor 3 is also become high because of done bit is getting high to the second timer. Let's take the third case. When I press the stop button, my binary output becomes 0. That's why my motor 1 becomes 0 because it's directly connected to the binary output. And the same time, you can see in the diagram, my first timer start counting, right? My first timer start counting from 0 to the preset value. The preset value of the first timer you can see is 10 seconds. That's why in this 10 second, my done bit is high. That's why my motor 2 become high for the 10 seconds, right? After the stop button is pressed, my motor 2 is high for the 10 second. As you can see in the diagram, my motor 1 is stop instantly, but my motor 2 is high and it will high for the 10 seconds when my first timer accumulator value is equals to the preset value. As you can see in the diagram also in the third rung, you can see the enable bit for the first timer is 0, but the done bit is high, right? So the done bit is connected to the motor 2. So my motor 2 is on. At the same time, similarly, my done bit is connected to the second timer. So second timer done bit is also high. That's why motor 3 is also high. So what happened in this case, when I press the red button, my binary output becomes 0. That's why motor 1 become off. As you can say, motor 1 is equals to 0. At the same time, motor 2 and motor 3 is in on stage. That's why motor 2 and motor 3 is represented by 1. When motor 2 is off, when my first timer accumulator value is equals to the preset value, my first timer done bit goes to the off state. That's why you can see in the diagram my motor 2 become off. At the same time, you can see the first timer done bit is connected to the second timer input. That's why you can see the second timer start counting from 0 to 10 seconds. I guess the diagram is clear to you. The second timer is start counting from 0 to 10 second. For that 10 second, my motor 3 become high, as it is clearly visible in the diagram also. In this case, means my second timer start counting from 0 to the preset value, and when the accumulator value is equals to the preset value for the second timer, my second timer done bit goes to 0, and the output connected to the second timer done bit will goes off after the 10 seconds. So finally, when we press the red switch, motor 1 off at the same time, and after 10 seconds motor 2 off, and after 10 seconds motor 3 off, right? Again I am repeating this process. In this case we have 3 motors, M1, M2 and M3, and 2 switches, one is green and one is red. Our process is, when I press the green button, all the 3 motors become high, and when I press the stop button or when I press the red button, initially motor 1 become off instantly. After 10 seconds, motor 2 become off, and after 10 seconds, motor 3 will be off. This is my process. So in this case, you can see we are using 2 T-off timer. First timer is connected to the binary input, and the second timer is connected to the first timer done bit, right? See, when I press the green button, my binary output become high, and binary output is connected to the motor 1. That's why motor 1 is directly on. At the same time, my binary output is connected to the timer 1. So timer 1 also provide the enable bit and done bit. At the same time, the done bit is connected to the second timer as an input. That's why my second timer also gets the supply. That's why it also provides the enable bit and done bit, right? So when I press the green button, my motor 1 is on because of binary output. My motor 2 is on because of first timer done bit, and my motor 3 is on because of second timer done bit, right? So on procedure is clear. Next case, when I press the red button. When I press the red button, you can see in the diagram, my B3, the binary output goes to 0. It changes their state, it goes to 0. That's why my motor 1 become off, and you can see in the diagram, my binary output is connected to the first timer. That's why the timer start counting to the preset value, and the preset value is 10 seconds. That's why the accumulator start counting from 0 to 10 seconds, and after 10 seconds my first timer done bit goes to 0. That's why my motor 2 will off after 10 seconds, right? At the same time, you can see the first timer done bit is connected to the second timer as an input, right? So when the done bit goes, first timer done bit goes to 0, the second timer start counting from 0 to the preset value, and the second timer preset value is also 10. That's why after 10 seconds, my second timer done bit goes to 0. That's why the output connected to the second timer done bit goes to 0 after 10 seconds, right? So finally, when we press the red switch, motor 1 off, and after 10 seconds, motor 2 off, and after 10 seconds, motor 3 will off, right? So I think you clear the T-off process. So that's all for this lecture. In this lecture, we covered the T-off timer behaviors and some example related to the T-off timer. In the next session, we can explore more on the timer programming or retentive on delay timers and the example related to the timers. Thank you. Happy learning.